Okay, so for this one, this is the summation notation. So this is a sigma, and the I is your first term, so the first, like, we're starting at 1, and then it's going to go all the way to 46, because whatever number is on top is the last term. And you're going to plug in from 1 all the way to the last term for whatever formula is here. So it's going to end up being 1 plus 2 plus 3, like all the way to 46. Or to make it like quicker on how to find it, you can use Arithmetic Series. And it's an arithmetic series because you're adding all of the terms together, so it's the sum of it, and the difference between all of them is plus 1 all the way to 46. So the equation would be Sn and A1 plus n over 2. Sn represents the sum, n is the number of terms, A1 is your first term, and An is your last term. So you're going to use all of the numbers from here to plug in for this. So the sum we don't know, because that's what we're looking for. The number of terms is 46, because we're going to 46. The first term is 1, and the last term is 46, because that's where we're ending, and you divide it by 2. So Sn equals 46 times 47 over 2, 6 times 23.5, and then the sum would equal 1081. And that's how you would solve for that one. Okay, for this one, we have to figure out what it is. So you know that they're all adding together. So this is going to be a series, but we need to figure out like the difference between them. So from 4 to 8, it could be times 2. Then if you multiply 8 by 2, it's the same thing. And then all the way down. So the difference, or the ratio, is 2. So this is going to be geometric series. And to solve for this, it's Sn equals A1, 1 minus Rn over 1 minus R. Sn is the sum, A1 is your first term, R is the ratio, and n is the number of terms. So for this one, it's Sn equals 4, because that's what the first term is, 1 minus 2, because 2 is the ratio of like multiplying between, there's 1, 2, 3, 4, 5, 6 of them, over 1 minus 2. So Sn would equal 4 times 1 minus 64, 1 minus 2. Sn equals 4, 63, negative 63, because it's bigger, negative 1, and you can just cancel out the negatives, so Sn would be 4 times 63, which would equal 252. Okay, so now we're going to do an arithmetic sequence 1. And we know that this is arithmetic because between the numbers, the common difference is it's adding 4 each time. And it's a sequence because we're not adding the terms together. It's like a list of numbers. So the equation to solve for this one is An equals A1 plus n minus 1 d. An is the last term, An is the first term, n is the number of terms, and d would be the common difference. So for this one, the last term is 24, the first term is 4, then the number of terms is 6, this one, and the difference is 4. So the 4 plus 5 times 4, 24 equals 4 plus 20, 24 equals 24. So it works out. Okay, so this one is a geometric sequence because it's a sequence because we're not adding all the terms together. It's geometric because the common ratio is you're multiplying each term by 2 to get to the next one. So the formula is an equals a1 r2. Yeah. An is the last term. A1 is the first term. R is the ratio between the terms, and n is the number of terms. So this one would be 128 equals 4 times 2 to the power of 6 minus 1. So 128 would equal 4 times 2 to the 5th, and 2 to the 5th equals 32. So 4 times 32 would equal 128. Okay, so for the pyramid of Salisa, on our worksheet there was a little thingy, so I just wrote it out to help so people see. So we're trying to figure out how many rounds it would take for the entire US population of 300 million people to join a pyramid scheme if it started with 3 new recruits and each 3 recruits had to get 3 people. Okay, so for this formula, I already got it. The formula is a geometric series because we're starting with one number here and we are multiplying it by 3 each time, and we're going to end up adding all of the terms together. So the ending number is 300 million. The first term is 3. 1 minus the ratio is 3. The number of terms we don't know. That's what we're trying to figure out. So minus 3. So the first thing we could do is we can divide this 3 out of that side and divide that by 3. So we have 100 million bajillion, which would equal 1 minus 3n over 1 minus 3. And the 1 minus 3 could be negative 2. And you could multiply that by negative 2 to get rid of it. And multiply this side by negative 2. So negative 200 million. 1 minus 3n. And you can subtract this one. So it's negative 200 million and 1, which is equal to a negative 3n. You can divide by that negative 1 to get rid of the negative on both sides. And then it'd be 200 million and 1 to 3n. And then you can do log to get rid of this. So since there's an exponent as a variable, so it'd be log 3 to get rid of that. And log 3. So n would equal log 10 200 million and 1 over log 10 3, and n would equal 17.4. Alrighty. Alright, part 2. We're trying to figure out the percent of total number of recruits at the end of the 17th round, because the end of the whole thing is 17.4, and they want to know how many people joined at the 17th round. So it'd be Sn, because we don't know how many people. A1 is 3. 1 minus 3, and then the number of terms is 17 because we're trying to figure out the end of the 17th round. So then Sn would equal 1 minus 129. 140,163 over a negative 2. So that would be then this is 5 times 3. 3 times negative 129, 140,162 divided by a negative 2. Sn would equal 3 times 6, 4, 5, 7, 0, 0, 8, 1. And Sn, that times 3 would equal 193,710,243. Okay, so that's how many people joined during the 17th round. Now, last but not least, the percent of people who joined in the 17th round. So we're going to take the amount of people in the 17th, or yeah, maybe 129, 140, 163 divided by 193, 710,243, which would equal 0.667. Then you'd multiply 0.667 times 100, and you would get 66.7%. How's it going?
Yes.
Okay. So I'm just going to read the question. It says, at Vaughn's grocery store, you stack apples into a square pyramid. Once done, you notice the pattern of the top 3 layers has 1 apple, then 4, and then 9. This pattern continues for 15 layers. So the first thing we have to do is create a summation notation to calculate the total number of stacked apples. So it says that the top layer has 1 apple, so that would be our first term. And then it says it goes for 15 layers. So 15 would be our last term in it. And to figure it out, so it's like 1 apple. Starts with 1 apple, then 4 apples, then 9, all the way to the 15th. So, if we do it I squared from 1 to 15 would be 1 squared, which would be 1. 2 squared would be 4. 3 squared would be 9, all the way to the 15th layer. So that is how you find that. Now 7b, it asks us to use the special formula for the sum of the squares for first n positive integers, calculate the total number of apples again. So, let's go back to this. 1, 4, 9, all the way to the 15th term. And to find the 15th term, it would basically just be 15 squared. And 15 squared is 225. So, that's our 15th term. Using the sum of squares formula is n equals n. Let's scratch that. N times n plus 1 times 2n plus 1 divided by 6. So n would represent the number of terms, or in this case the number of layers. So it would be 15 times 15. Why is it happening to me? 15 times 15 plus 1 over 2 times 15 plus 1 all over 6. So it would be 15 times 16 times 2 times 15 is 30, so 30 plus 1 is 31. So you'd multiply 15 by 16, which would equal 240. Multiply that by 31, and this is over 6 still, divided by 6, which would equal 7,440 divided by 6, which would equal 1,240. That's the sum of squares. Okay, so for number 8, I just wrote out real quick how you find out like the years thingy. So if year 1 we start out with $6,000 and there's a 7% annual interest, you have to multiply that by 1.07, which is basically 7%, to figure out how much you're going to get in year 2. Then you do it all the way until year 32. So this one is a geometric series because you are multiplying each one by the same ratio and you're adding all the terms together, so it is a series. So for A, formula is E1, 1 minus R, 1 minus R. We don't know the sum yet, and that's what we're trying to find. So if we start out with $6,000, minus the ratio is 1.07, and the term that we're looking for is 32.07. 6,000 8.715 divided by negative 0.07. I hear your stomach. I'm hungry. You can just cancel out those negatives. And then the 7.715 divided by 0.07 is 110.218, and that times 6,000 is $661,308.93, and that's how much you have after 32 years. Now,
Yeah.
yes?
Yes.
Are you still going?
Yes.
Or did you stop
No.
it? Okay. B, it's asking how much was added to your retirement account in just like the last year. So it'd be from like year, like the 31st year to the 32nd. So we just need to figure out how much is the 31st year. So we could do the exact same thing. SN equals 6,000, 1 minus R to the 31st year, 1 minus R. Just gonna do this real quick. 1 minus 31. Or negative 0.65. So we'll put 6,000 equal 6,000 times 102.07, and in the 31st year you would have $612,438.25. So this is the 31st year, and this is the 32nd. And to figure out how much you made, you can just subtract the two. So it would be 661,308.93 minus $612,438.25 to figure out the difference, and it would be $48,870.68. So that is the difference. Now, C is asking us, write a recursive rule for how much gets added to your bank account every year. So our rule could be AN, because that's the term that we are getting, AN minus 1, and that would represent the previous term. Times the 7%, because that is our ratio, plus the $6,000, because that is what we start with. And that's how much we're putting in each month, so we always add the 6,000 for each one. And lastly, for D, it asks, explain when your account grows the most and why. Well, I'll just explain it. Our account grows, no, record this, dude, so I can show it. Our account grows the most between the last 2 years, so from 31 to 32, because it's increasing by $48,000, more than $48,000. And from year 1 to 2, it's only increasing by $420. So the more time passes, the more money that you end up getting from it.